half a t square. Third one, b square minus u square equal to 2s. Now we have to start fourth equation of motion. What is that fourth equation of motion? What is the use of that fourth equation of motion? Generally we have to find that displacement in n seconds. We can use that second equation. But we have to find the displacement at nth second. We can use fourth equation. Which is second at nth second. What is the meaning of nth second? What is the difference between second equation of motion and the fourth equation of motion? In which situations we have to use that condition? Okay, just identify that. So in 0 second, what is the displacement? 0. Next to 1 second, we have to find out that displacement. We can use that formula as equal to EP plus a half a t square. Is that? So 0 second, 1 second, 2 second, okay, 3 second, and up to so on. We have to consider that n seconds. Have to consider n seconds. Okay, so here we can find out that displacement in 1 second, 2 seconds, 3 seconds, 2, so on. In n seconds, we have to use that formula s is equal to et plus half a t square. Now we have to find that displacement at nth second. The meaning of nth, up to this point, the meaning of nth second is one gap between two conjugative incident. It's one gap. It's one gap between two conjugative incident. We have to consider this point. What is that gap between 1 second, 2 seconds? What is the gap between 2 and 3 seconds? Okay, what is the gap between? So here n second, before number n minus 1 second. Next number n second. Next number n plus 1 second. Next number n plus 1 second. What is the gap between n minus 1 and n second? So here identify that the gap between two incidents. What are the two incidents? 0 second and 1 second. The gap between 0 and 1 second is represented first second. Okay, here gap between 1 second and 2 second we represent second second. Here gap between 2 second and 3 second I represent third second. Okay, so in that time we have to find that displacement. We have to find that displacement. The displacement is called as displacement at nth second. Displacement at nth second. At nth second we have to represent nth second. So find the displacement in first second. Okay, we have to calculate the displacement in first second. Next one, we have to calculate the displacement in second second. Next, we have to calculate the displacement in third second. Like that, we can calculate the displacement up to nth second. So displacement in nth second is Snth. Displacement in nth second is Snth. Understood? Now we can identify this point. Snth nothing but displacement difference between two incidents. Okay, what are that two incident time? So one incident time n second, another incident time n minus 1 second. Find that displacement at nth second. Which is second? At nth second. Displacement at nth second. Displacement at nth second, Sn equal to Sn minus Sn minus 1. Understood this point? Sn equal to Sn minus 1. Okay, so now just identify that if t equal to small n seconds. Don't know that value. Due to that reason we consider as n. Okay, t equal to n seconds. Then Sn equal to, we have to write this point, then Sn equal to un plus 1 by 2 an square. Un plus 1 by 2 an square. What is the formula for displacement? Displacement S is equal to ut plus of at square. Okay, so in t place we have to substitute n seconds. Sn equal to un plus of half an square. Okay, so here next point in n minus seconds, so how much displacement to cover that body? We have to find out if t equal to n minus 1 second. If t equal to n minus 1 second, then find the displacement. So what is the displacement? N minus 1 equal to u of n minus 1 second plus 1 by 2 a into n minus 1 whole square. So now we have to represent that equation for Sn, the formula Sn equal to Sn minus 1. It is a first equation and it represents second equation and it represents a power equation. From 1 to 1, 3 we can get fourth equation of a motion. Understood? We have it out. So now we can continue our class. Now here just identify this condition. So from first, second and third equation. So write point from first, second and third equation. Now we have to write that point. Sn equal to, here Sn equal to Sn minus 1. In Sn place we have to substitute this value. So write un plus 1 by 2 an square minus, okay, in Sn minus 1 place we have to substitute so third equation values. So right here of un minus 1 plus 1 by 2 a into n minus 1 whole square. Understood? We have it out. Okay, students, just identify this equation. Sn equal to un plus half n square minus of u of n minus 1 plus 1 by 2 a of n minus 1 whole square. But we have to observe that n minus 1 whole square, n minus 1 whole square, it looks like a minus b whole square. What is the formula of a minus b whole square? A square plus b square minus 2ab. Yes or no? Understood this point? A minus b whole square formula equal to a square plus b square minus 2ab. Now write this point un plus 1 by 2 an square minus, here minus, directly we have to represent. In another step we can multiply with the minus. So u and minus u plus 1 by 2. Okay, a of n minus 1 whole square. N square plus 1 square minus 2n. Okay, so now we have to apply this basics. Okay, plus into plus equal to plus, minus into plus equal to minus, plus into minus equal to minus, minus into minus equal to plus. Some students are getting confused with these basics only. Yes or no? I saw in many examinations the students did the mistake with this multiplication. It's not difficult for the students, but the students are confused with that multiplication. Okay, just identify here un plus 1 by 2 an square minus into plus. Minus into plus minus un minus into minus plus u minus into plus minus 1 by 2 an square. Okay, minus into plus minus, have to consider that 1 by 2 a minus into minus plus, so consider that both are getting cancelled. Next one, plus half n square, another one minus half n square. We can cancel it. Next, u, one term is there, another one minus 1 by 2a, another one an. So write u plus an minus 1 by 2a. Now common that acceleration. Here u plus a of n minus 1 by 2. Therefore n minus 1 by 2. This equation represents the fourth equation of motion. Write that fourth equation of motion Snth equal to u plus a of n minus 1 by 2. Okay, represent fourth equation of motion. Or this formula we have to represent it in another way. Snth equal to u plus a by 2 into 2n minus 1. Understood? Okay, this formula represents fourth equation of motion. You have any doubt? Not also. Okay, students, what is the difference between second equation and fourth equation? Second equation is used to find the displacement in n seconds. But here, fourth equation used to find the displacement at nth second. That is the difference. Okay, now we can discussing some example related to this formula. Okay, students, are you ready? So, few seconds we have to observe the board. Next, we can continue our class. Okay, students, now we have to discussing that example problem related to fourth equation of motion. Now, up to here, one body reaches certain height from the ground. Now, just identify that condition. Here, initial velocity u equal to 0 meter per second. So, what is the time? Time equal to 0 seconds. Okay, initially at rest u equal to 0 meter per second. After 1 second, it reaches point here, initial point A. After 1 second, it reaches to point B. How much time taken? 1 second. Here, next to 1 second, it reaches to another point C. So, total time taken by the body 2 seconds. Okay, next to 1 second, it reaches to point D. So, here total time taken, how much? 3 seconds. Finally, it reaches the ground at n seconds. How many seconds it takes? N seconds. 0 second, 1 second, 2 seconds, 3 seconds. Finally, the body reaches to the ground in n seconds. Okay, now find out that nth second. Find out that nth second between AB. How much? First second. Okay, so here between B and C, so we have to calculate that n time. How much n time? Nth time? Nth time means second. How much? Second. for you, Snth equal to u plus a by 2 into 2n minus 1. Your body releases in vertically downward direction. Yes or no? Here identify that acceleration is also called as acceleration due to gravity. So here sign convention for acceleration due to gravity is plus. What is the reason? Here velocity of a body gradually increasing in vertically downward direction. The rate of increasing velocity is positive acceleration. The rate of increasing velocity is called as a positive acceleration. Because of that reason, we have to keep that sign plus. Understood, students? Okay, we have any doubt? So please concentrate here. So this value approximate to 10 meter per second square. Okay, 10 meter per second square. Find out the displacement at first second, displacement at second, displacement at third second, displacement at nth second. You have to find out. Here x1 value equal to how much? Initial velocity of a body, how much? 0 plus a value, acceleration value, we consider 10 meter per second square. So right here, so 10 by 2 into 2 into 1 minus 1. Okay, here that value 10 by 2 value 5 into 2 into 1 2 minus 1 value how much? 1 also, that is equal to 5 meters. Next we have to find out the displacement at second. Okay, displacement at second, substitute 0 initial velocity how much? 0, directly we have to write 0 plus 10 by 2. Okay, here n value only changed, so 2 into 2 minus 1, that is equal to 10 by 2 value 5 into 2 jars 4 minus 1, 4 minus 1 value 3, 5 3 jars 15 meter. Okay, at third second we have to find out that displacement. So initial velocity how much? 0 plus 10 by 2. Okay, so just 10 by 2 into 2 of 2 minus 3 minus 1. So just to simplify, 2 1 just 2 5 just 5 into 2 3 just 6 minus 1, that is equal to 5 into 5, that is equal to how much? 45 meters. Okay, understood. So in these three conditions we have to identify that displacement at first second how much? 5 meter. Displacement at second condition 15 meter. Displacement at third second 25 meters. Okay, we have to compare that ratios. Here displacement at second condition 3 times more than displacement covered in a first second. Yes or no? So just identify that condition. X2 equal to 3x1. Okay, here x1. Okay, here 3x1. Here we have to identify that x3 value. How many times more than initial displacement at first second? So 25. So initial displacement at first second how much? 5 meters. So 5 into 5, 25. So that we have to represent 5 into x1. Again we have to calculate that displacement. So 4th second, 5th second, 6th second and 7th second. Then you have to get that. So ratio of displacement at first, second, third and nth second. So S1 at first second displacement, at second displacement. Okay, next one. At third second displacement. Okay, up to so on it is equal is to displacement at nth second. Equal to how much? 1 is to 3 is to 5 is to 7 is to up to so on 2n minus 1. Okay, 2n minus 1. It is a very important relation expressed by this example. Okay, very important relation. This relation is expressed by this example problem. We have to concentrate on this example problem. What is the necessity of nth equation? That that fourth equation of motion is used to find out the displacement at nth second. Okay, understood. Okay, second equation only used to find the displacement in 1 second, 2 seconds, 3 seconds. But Here, fourth equation of motion is used to finding the displacement at a particular second. Okay, understood? Students, if you have any doubts or there means you can give that comment and give that reply for you. Okay, students, bye. So this is MC sir. So don't forget, you can like and subscribe my channel.